Hi everyone, welcome back to the channel Coding Help. In this video, we are going to solve the problem of weekly contest 492. In this problem, we have given find the smallest balance index. We need to find balance index, and we have given n nums integer array, and we need to find the balance index I if sum of element is strictly to the left of I means whatever index we are choosing, this one index for example we are choosing, so we have to find a strictly lesser index element sum left side equal to product element strictly to the right of I. So this should be the right, so strictly right, it means this element ith index element won't be appear in either sum or either multiplication, right? If we don't have element, for example we are choosing this element, if we don't have element in left side, so what will the sum? Zero. If element is here, index is here, so sum will be, these are all elements sum, and right should be, what should be right? They are saying consider product as a 1. Return an integer denoting the smallest balance index. If no balance index exists, return -1. Okay, a smallest balance index. In this case, here you can see if you will choose this index, so what will the product? Product will be 2 and sum will be 0. So it won't be equal. We'll go for another index. This one index left sum is 2 and product is 2. So we will return this one as a balance index. Okay, so here we are getting 1. And here in this example, again we'll check from left this one. Sum will be 0 and product will be product of these all elements. Again here it will take, then product will be here greater than this sum. Now take this one, sum is 10 and product is 10, so we will return the index 2, right? Now let's go to the constraints. So nums of length is 10 to the power of 5, right? But nums of I is 10 to the power 9. Okay, so we can do it using order of n, right? We'll traverse from left. Once we'll take the product array, suffix product array, and we'll try to do sum from the left side and try to make it equal, or nums of I greater than 1 and 10 to the power 9. So our product never becomes 0. Never, yes, never becomes 0. Now here nums of I 10 to the power 9, and we know that if we will multiply these all element to 10 to the power 5 times, so what will happen? 10 to the power 9 into 10 to the power 9 into 10 to the power 9 until 10 to the 15 times, it won't be stored into the long and more than that. So how we will handle that? So what we can do? By the way, this problem is also simple problem. What we can do, we will compute the product. Okay, from suffix product, we will compute the suffix product. Okay, because if we will do 10 to the power 9 into 10 to the power 9, it will overflow long, long also. Okay, so we can't store. So what we'll do, first we will do the total. Okay, so our product should not be greater than total. Got it? Why our product should not be greater than total? Because if we'll go beyond the total sum, okay, total sum, it means that we can't make it equal left side element to the right side product. Because if product is now going greater than all of the sum, so we never will make it equal. So in that case, what we will do, when when our product become just you can say greater than equal to sum of all element plus 1, we will start putting product as a sum plus 1, right? Okay, did you get or not? For example, we have element 1 2 3 4 5. Okay, sum is 3 15. Sum is 15. So product should not be greater than 50. What we'll do, we'll like start putting this one multiplication 5. 5 for the 20. This is greater than sum. So when next element will come, we want to put here 60. We'll put just 20 or 21, 21 or 21, 21. Okay, like that. Now what we can do, in some case what will happen, if you are checking product is equal to previous product is 20, and now current element is 3. Some case what will happen, for example, our sum is long max minus 1. It will be stored into the long max, but new element is coming 10 to the power 9. So it will overflow long. Okay, it will overflow long. So in that case, what we will do, we want, in this case, what we will do, we want multiply for checking. Okay, here what we are checking, a product is our previous like product is greater than equal to sum plus 1. We are checking like that one. What is product is our previous product 20 into 3 greater than equal to our sum. Okay, now what we can do, like some person. Now what we can do, we'll do 20 greater than equal to sum plus 1 divided by 3. We'll do like this because this will overflow, or sometimes it will lead to this one long max plus minus 1 into 10 to the power 9. It will overflow the long. So that's why we will use division here, right? And likewise we will store the product from the right. You got it? Like here was 4 and 20, like that, and 21, 21, 21, like that. Got it? And we'll now, in finally what we can do, start doing sum. If we'll take this index, left sum is 0. We'll take this index, left sum will be 20, whatever array value we have. Again, we'll come here, we'll do sum, we'll come here, we'll do sum, and we'll try to check with right product. Okay, if we will get equal from left sum or right product, there only we need to return the index, or height index will return the answer. So you can say it's easy, but there is one multiplication trick is there. Okay, now let's directly jump into the code and understand the code. Here we have taken total sum, right? And this is suffix product or suffix product of right. If we don't have any element in from the right and minus 1 index, we will put product as one. From n minus 2, previous product will take I plus 1 and current element, right? If previous product is equal to minus 1, or previous product greater than total sum divided by current product, what? Oh, okay, here whatever we have shown you this thing. Okay, or I told you to put here 21, but I am taking here as a minus 1. Okay, uh, previous product is minus 1, or suffix product is minus, or otherwise if previous product greater than total sum divided by current value. So we put as minus 1, otherwise simply we will do the suffix product, right? Finally, from the left side, we will take sum. Okay, we'll take the sum, and our when our current left sum is greater than suffix product of I, right? So we'll return the I as an index. Either we'll keep doing sum. If we are not getting any answer, we'll return as a minus 1. Okay, got it. Just run the code, try to understand one more time. Either go for the my explanation section. Definitely will get the idea what we are doing. Okay, now let's see the another problem of weekly contest 492, that is minimum operation to sort a string. We have given a string of lowercase English letter, and we need to sort the string. In one operation, you can select any substring of hash that is not the entire string. Okay, we can't take entire string. Either if you will take entire string in one sort, it will be sort. So for any array, we will use only one operation to sort. But they are saying we can't take entire screen. It is non-decreasing, descending alphabet order. Okay, non-descending. Return the minimum number of operations to make as sorted in non-decreasing order. If it is not possible, return minus one. Okay. Let's understand with some example. They are saying we have given some string. Okay, so for example, A, B, C, D is there. This is already sorted, so leave it. Take as A, C, D, A, C, D, P. Right. So they are saying, so how many operation we can sort? So they are not saying to take all and do sort. If we will take all, we will sort in once. But they are saying we can't take entire. So we will try to, we'll become greedy. So we will take this one and this one. First take A, C, D and sort. This is already sorted. So we won't sort it. And now we'll take this one. CDB will sort it A, B, C, D. In one operation, we are able to sort it. Right there, only one operation needed. Good. For another, let's take another thing where two operations is needed. How we can check two operation is needed? So we will take as a C, D, B, A. In this case, how many operations needed? We will take one operation here. So this will give you C, A, B, D. Okay. In second operation, what will do? A, B, C, D. Here, two operation needed. Right. So we will think that we can solve either one or either two, because we'll take left side element, just one element left, and another only one element left in this one left side. So mostly we'll think that we can solve using maximum two operation, right? But you know what we can do in this case? Let's take B or A. Can we sort it? Can we make it sort? Because we can't take all the elements, so we will take this one or we will take this one. You will sort this B or A. Finally, it will come as a BA. So any two length unsorted string, we can't make it sort, right? So we need to return here -1. Can we check for three operation? Three operation, what we can do? For example, we have CBA. How many operation it will take? Take this one, sort it. CAB. Take this one, sort it. ACB. Right? Take this one, sort it. ABC. Can you do using the two operations? Just try to think. I have taken from this side. You can take from this side also. Like C. If you take CB, so BCA again, you will sort it. You will give BAC, again you need to sort ABC, right? It will take three operation. What you can observe here, we can observe here that if our first element is the maximum element or last element is the minimum element, okay, first element, for example, we have a string, anything, a string F, B, C, D, um, okay, A, B, C, okay. Now here you are taking A. In this case also it will take three operation. Good. So because when we are sorting, this will become sorted. Still, this is not sorted. Next time you will sort, you will put F here, not here. Or next time you need to sort to take F at the right side. So definitely it will take three operation. Now what will happen? When element is duplicate, F, B, C, D, A. In one sort, what you will do, A, B, C, D, F, right? Here F is there. Now again you will do sort A, B, C, D, F. Okay, see, if our element is duplicate, if our element is duplicate, what, or like for example in three operation case, right element is duplicate, right is the smallest element, but that smallest element is duplicate element, or first element is the left element, but this element is duplicate element. If any one of them is duplicate, we can do still using two operation, right? So what was our observation? Now try to understand the case, how many cases are there. What we'll check, first we'll check that our string is sorted or not. If sorted, we'll return zero operation. If not sorted, and maximum element is at the end, okay, or minimum element at the beginning, okay. If minimum element is at the beginning, so we'll take whole element, we will sort it in one operation. So what will return? We will return one operation. So we'll check that left element is minimum among all element, or right element is maximum among all element. If it falls under this condition and not sorted, we will return one. Now we will check for three operation. How we can check? First element definitely should be greater, not greater, it means the highest element, okay, and last element should be lowest element. For example, this should be Z, this should be A, or there is no duplicate. It means that we will return three operation. Either we will return two operation. Okay, we have checked zero operation, one operation, three operation case, and the rest of the thing, it will comes under operation, right? So let's why I have left two, because we know that this condition, but for two operation there are a lot of things is there, okay, lot of condition is there, or we know that at most it will take three operation, okay, and minimum zero operation is there, one operation is also there, and two operation is also there. But for operation two, we need to check different conditions. So that's why rest of the thing we count under the second operation. Okay, this is the okay. So what for this test case, what we can do if we have two element only, size is 2 and element is not sorted. In that case, we'll return the -1. That condition is also there, -1 case. Okay. So now let's go to the code. Here in this code, we can see that we have taken length and minimum character or maximum character is there. We'll try to take maximum or minimum character from the string. We'll check sorted. If sorted, we'll return 0. If not sorted, and length is 2, right? If it is sorted, then return 0. If not sorted, it means and length is 2, will return -1. Okay, right. If we will check either minimum character is at 0 index or maximum character is at last index. So just we'll take the rest of the element and we'll sort it. It will be sorted. So it will take only one operation. Either we'll check for first maximum or minimum element, last first minimum or last maximum element, or we'll check the where is our minimum character. Here we have find minimum or maximum character, right? So we'll check here first minimum index, okay, and this is last maximum index. Okay, if first minimum index is equal to n minus 1 or last maximum index is 0, we will return 3. Okay, uh, okay, and the rest of the case will return 2. Now let's see, try to understand this code again. So what we have taken here, first minimum index. First minimum index, wherever we have previously find minimum character or maximum character, right? If we are getting minimum character anywhere, we are scanning from left to right. If we are getting minimum character at, if we are, for example, we have a length of a string is 5 and our first or minimum character is at third place and fifth place. Let's understand with this example. For example, F is there, F, B, D, A, C, A is there. Okay. So here we can check this is the maximum element or minimum element. According to our see that when we'll see first element is maximum element, last element is minimum element, we will return 3. But we are getting duplicate. That's why we are trying to first minimum element. First minimum, where we'll get first minimum, here we'll get what is index is less than our maximum index. So that is, you can say 0 1 2 3, but the last index is 5. Okay, this one, and last maximum element means here F is there and B is there, D is there, F is there, C is there, A is there. Try to find last maximum. This maximum, this maximum, this maximum. Here we have get the last maximum. We will stop it here only at a third index. We want to go here for the maximum element. If still we are able to move our index, if there is no duplicate, we will definitely go till end. If this is not there, we'll definitely go till end for A and will come till beginning for the maximum element. So that's why here we are checking the condition. What condition we are checking? Our first minimum index is n minus 1, means first minimum element is at the end, or last maximum index is at the 0. In this case, we'll come here for 0 for F. If this condition will be true, we'll return 3. Either for anything, we will return 2. right? So this code is accepting here, we can see. Okay, okay, thanks. Let's go to the another. Now let's understand the last and hard problem of the weekly contest 492. And this problem is saying minimum cost to partition a binary string. Okay, we have given the binary string or we need to partition it. Okay, you are given a binary string s and two integer, that is enc cost or flat cost. For each index I, s of I is equal to 1 indicates that ith element is sensitive, right? S of I is equal to 0 indicates that it is not. Okay, where is 1, that is sensitive, where is 0, that is not sensitive. The string must be partitioned into segment. Okay, we are partitioning the element into segment. Initially the entire string forms a single segment, all right? For a segment of length L containing X sensitive element, we have segment of length is L containing X sensitive element. X, if X is equal to 0, okay, means L length segment is there or X is sensitive. X sensitive element. If sensitive element is 0, we don't have any one. So what will the cost of that partition? Flat cost. What is the flat cost is there? If X greater than 0, so like we have at least 1, 1, 2, 1. So there is sensitive. So what will the cost? Length of our that is substring. Then we are how many number of ones are there, and then we are multiplying enc cost. And what is this given? They are saying segment length is even, we can split that segment of equal length, like length is 8, we can split into 4 into 4, and cost of this split is the sum of cost of resulting segment. Okay, what is the cost? Left sum of left segment or right segment. Return an integer denoting minimum possible total cost over all valid partition. Okay, now let's understand this example and what will the minimum cost. We have this 4 length string, so what will the cost? Length is 4, x is very sensitive element, 2 sensitive elements there, 2, and enc cost is 2, so it will be 16. Now we can divide it, 1 0 and 1 0. Length is 2, now x is 1 and cost is 2, 2, 1 and 2. This will be 4, 4, cost will be, oh sorry, 8. So previously it was 16, and when I have divided, we are getting 8. So now we have reduced. Now till now we have minimum element 8. Because length is even, so we can divide it 1 0 1 0. Okay. Here x is 1, length is 1, x is 1 because sensitive element is there, and enc cost is 2 because x is 0 because sensitive is there, 0, 0 element is sensitive. So we'll take as a 1 cost. Here also 1 into 1 into 2, and here cost will be yeah, flat cost. Flat cost is 1 and flat cost is 1. So what will be the total? 2 plus 1, 2 plus 1, and total all the thing 6. Now this is lesser than 8. So our answer is 6 because this is the minimum among all the different partition, right? So we can do like this one. Okay. So now see the approach. What we can do, we have given any string 10101 like that. First, we will try to find the cost without partitioning. Partition length and x is sensitive element, enc cost like that. If length is even, we will try to split from the middle. Okay, we not will try, but they are saying even length into two contiguous equal length. They are saying if length is even, then we can split from the middle only. Equal length string. Okay, some equal length string. So we are separating from middle or dividing from middle. From that suggestion, we will try to make the find the cost of this one and cost of this one. We try to, and we will do sum of that cost, and we will try to find if that is minimum. Okay. Again, we will check length is even or length is even. We'll divide it, right? We'll divide it and find the answer. And again, we'll do sum. Like that, we will do it until we are able to divide this string. Other we will stop there. Okay. Now let's see the code. That is our approach. Okay. This is our function, ANC cost, flat cost. So what we are doing, we are checking. First, we are checking how many ones are there. If ones are there, we are increasing the count and pre-sum, like that is the one count or sensitive element, we can say. So this is okay. We are checking in pre-sum. We are storing the count of one. Now we are solving the problem. Now in solve here we are sending left to right, left index or right index. So we are finding the length and now we are finding number of ones. What will the number of ones? Till a right point, what is the one? And we need to reduce left how many number at left minus one index, right? If once is zero, just we return flat cost. If there is one, so we'll calculate this cost. Okay, right. Then if we check length is divisible by 2 or not. If length is divisible by 2, what we can do? We can divide into two equal substring. Right? We are trying to find the mid index. What will the mid index? So we are dividing equally here and we will try to left to mid and mid plus 1 to right index. Got it? And how we are dividing mid this one? So we can check using here, yeah, 0, anything is there. 1 2 3 4 5 6 7 1 2 3 4 5 6 7 only take here. This is 2 3 4 5 6 7. Index is 7. Left mid index is 6. Left plus right divided by 2 minus 1. 2 plus 3 minus 1 means 4. 3 4. Okay, we divide here and here like that. That's why we have done. So you can do this calculation. It is simple calculation only. And whatever cost is coming, if that cost is lesser, okay, if that cost is lesser, we are updating the cost, or finally we are returning the minimum cost, right? So let's run this code. For simple test case, it's getting passed. Yeah, now it's running perfectly. Okay, thanks for watching. We will see you in the next video.